All right, folks, welcome back. Here we are looking at quadratic functions. This is part 2. What we're going to talk about right now is finding the x-intercepts, or the zeros, or the roots. And what you've got to keep in mind is an x-intercept is when the y equals 0. So if you remember a minute ago, we tried to find the y-intercept and we made the x equal to 0. Well, when we're trying to find the x-intercepts, the y is equal to 0, which is part of the reason that they call them zeros, okay? And so the first step in typically doing that is going to go ahead and make our equation equal to 0. And then we're going to use a zero product property and then solve it. If it's not factorable, then generally we're going to try working the quadratic formula. Now, I know that you've learned how to complete the square and all that, and there's definitely a use for completing the square. But I've got to tell you, if it's me, if it's not factorable, then I'm probably just going to go right to the quadratic formula. Anyway, let's take a look at this one here. If I'm going to try to find the x-intercepts, then what I'm going to do is make it equal to 0. So I'm going to make this a 0. And now I'm going to factor it. And it looks like this. And once I've got two things multiplied together that equal 0, well then this thing or this thing must equal 0. And so now I can rewrite them as two separate equations and then solve them independently and find out that x is equal to -1 and then x is equal to -5. And what you got to keep in mind is what we've just found is we've just found the x-intercepts. We've found the value of x when y equals 0. All right, so let's try this one. Okay, so for this one, for b, again, we're going to try to make it equal to 0, and then the next thing we're going to do is we're going to try to factor it. And what I'm going to do is I'm going to kind of visualize this. You notice how the a is equal to 2, so that means we would use the AC method. But before I go to the trouble of writing all that down, I'm just going to do some of it in my head. So a times c, well, that's going to be 10. And then what I need to know is if there are two numbers that multiply to get to 10, but also add to get to -9. And see, I can't think of any. 2 times 5, well, they add together to get 7. And 10 and 1, they add together to get 11. But I can't think of any way to multiply two numbers together and get 10 and then have them add to get 9. So that means I'm going to switch over to the quadratic formula. And of course you know the quadratic formula, and I got to tell you, it's just something you're going to have to memorize. So if you haven't memorized it yet, you got to work on that. -b plus or minus square root of b squared minus 4ac all divided by 2a. I don't care if you sing a song, I don't care what you do, but this is something that you're just going to need to remember. So if you haven't memorized it, it might be something to work on. Anyway, all I'm going to do is substitute my values in. I got a is 2 and -9 is b and c is 5. And so when I do that, I put it inside here. And then what I'm going to do is I'm going to simplify underneath the radical. And I get 9 plus or minus square root of 41 over 4. And that, I want you to understand that when people write it this way, they sometimes forget about the fact that they've actually written two things. It's 9 plus square root of 41 over 4, and it's 9 minus square root of 41 over 4. So I find it helpful sometimes to write it separate, because if I'm looking for the x-intercept, and maybe sometimes, like if I'm actually going to graph it, I'm going to want to do this as a decimal. I'm not going to graph 9 minus square root of 41 over 4. So if I actually do that, I'm going to end up with 3.85 and 0.65. So those are my x-intercepts. Now, graphing. If I'm graphing a quadratic and I've got a vertex, well, that's a pretty good start. And then if I've got the y-intercept, that's nice. I can plot that point. And if I've got two zeros or x-intercepts, that's really great. And then you'll know right now that if this point is 1 away and it's up here at 5, well, if I go here and go 1 away, it's also going to be at 5. And so I can plot that point. And you know what? If I can find these points, that gives me a lot of information about the graph, and then all I got to do is color it in and fill in the gaps. Put an arrow on each end, and I've got a graph. So let's take a look at the other one we did. We did 2x squared minus 9x plus 5. And again, we have a vertex. It's not the prettiest, but it's a vertex. And so we would plot that. And then we've got a y-intercept, and we would plot that. And then our x-intercepts. And again, we're kind of estimating here. And the same kind of notion here. If that's there, well, then I go off for a little bit, and that's going to be up here. And then all I do is sketch it in. So if you can find the vertex, the y-intercept, the two x-intercepts, I mean, you've got a good amount of information as far as graphing a quadratic. All right, now completing the square, writing it in vertex form. There's two ways that you go about writing a quadratic in vertex form. And one is to complete the square method, and we'll talk about that right now. The first one you do is, when you're going to complete the square, is you isolate the x squared and the x. Get rid of any constants if there is any. And then you factor out the a. So if there's a number in front of the x squared, you factor it out. And then you take the b term and divide it by 2 and square it and add it to both sides. And then you factor the new trinomial. So let's go ahead and take a look and see what that looks like. Here I've got this. And if I'm going to get rid of the 5, it's going to look like that. And now I've got my two terms, and the number in front of the x squared is a 1, so I'm pretty happy about that. And all I got to do is take the 6 and divide by 2, and then square it, and that's going to be 9, because 6 divided by 2 is 3, and 3 squared is 9, and I add that to both sides, and I end up with this. And see, now I've got this perfect square trinomial. The reason we call it completing the square is we're creating a perfect square trinomial. And what makes it a perfect square trinomial is it's going to be a binomial times itself. And in this case, it's going to be x plus 3. Now all I got to do is take the square root of this, copy the sign down, and square root this. And I've got that perfect square binomial or perfect square trinomial factored. It's x plus 3 times x plus 3, which is x plus 3 squared. And now all I got to do is subtract the 4 on both sides. And then I've got it written in vertex form. Okay, so now that we've got it in vertex form, I mean, it's nice. The nice thing about it is the vertex is staring us right in the face. And we've already found it for this one. I don't know if you remember what it was, but in this case, all I've got to do is take this number and take the opposite of it. It's going to be -3, and then this number, it's going to be 4. And you're like, why is it in the opposite? Well, look at the normal formula, the standard form of it. It's x minus h. Well, if this is x plus 3, that means the number I put in there must have been a negative, because minus a negative is the only thing that's going to turn into addition. Anyway, my vertex is going to be -3, -4. So that's the first method. It's actually doing completing the square. Now, the other method is to find the vertex, which we did a minute ago, and then plugging in the a by substituting it into vertex form. So let's take a look at that. And again, we've already done this once with this. I want to find the vertex. It's -b over 2a, and then I find it's -3, and then I substitute the -3 back in, and I get a -4. And now I know the vertex. And see, if I go to this form and write it down, all right, all I got to do is put this here, and this here, and this here. And so I know that this h, this one side here is going to be the opposite, but it's not really difficult to take the vertex and the a and plug it back in. And there's some people that think that's a lot easier than doing complete the square. And I think that they're both good ways. So just want to make sure you saw both those. So if I'm graphing a quadratic, a couple different things. First, this is x squared. And if I were to multiply it by -1, well, I hope you know what's going to happen. What's going to happen? Yeah, it's going to reflect over the x-axis. If I multiply the whole thing by -1, it's just going to reflect over the x-axis, okay? And then what if I put a -3 at the end? What's going to happen to this guy now? Transformation. What's going to happen to this graph? Yeah, it's just going to shift down by 3. And then what if I take and I subtract 3 from just the x's? Notice it's not at the end. It's in the inside. It's with just the x's. This is going to cause it to do what? Yeah, it's going to cause it to go left or right. Which one is it? Yeah, it's going to go to the right. It's always the opposite of what you feel like it should be. -3 feels like it should go to the left, but this is actually going to go to the right. So this is going to be shifted over 3. All right, so what I want you to get is that when I have the quadratic and then I shift it over here into this form, well, this is basically telling me what happened when it started from going from x squared. Well, it moved to the left by 3, and then it went down by 4. And so I already know that it's going to be shifted over here, left and down. And so that's a little bit of something about graphing you got to keep in mind, transformations. And then discriminant. Last but not least, the discriminant is the thing inside the quadratic underneath the square root. All right, b squared minus 4ac, that's the discriminant. Not square root, just b squared minus 4ac. And the discriminants are used when situations where all I need to know about are the roots or how many times it crosses the x-axis. So let's go ahead and just kind of do this real quickly. If I've got x squared plus 6x plus 5, and if I use the quadratic formula, keep in mind, it's the same one we've been doing, so it's factorable, but we're using the quadratic formula. If I do the quadratic formula, what's going to happen is I'm going to end up with my discriminant's going to be 16. Now, that's a perfect square. So that means that's going to be negative 6 plus 4 divided by 2, and negative 6 minus 4 divided by 2. That's going to become a nice rational number. So the thing to remember is if the discriminant is positive, there's going to be 2 roots, and they're both going to be rational if it's a perfect square. So that's the first thing. Discriminant. If it's positive, you know there's going to be 2 x-intercepts, and if it's a perfect square, you know it's going to be rational. Now, in this next situation, let's go back and look at the graph. So what's that look like graphic-wise? Well, again, there's going to be 2 x-intercepts. All right? If the discriminant's positive, there's going to be 2 x-intercepts, which that's what we obviously see. All right, so look at this next one. Do the same thing. We'll fill this in the quadratic formula, and when I go and do this, I find out my discriminant's equal to 0. All right, now, this is x plus 3 times x plus 3. Right? Okay, so in this case, what happens is if the discriminant is equal to 0, there's only going to be 1 x-intercept. It's going to be a double root. And if it's a perfect square, well, obviously that's going to be rational. This is going to be negative 3, 0. And again, graphically, it's going to look like this. If the discriminant is equal to 0, it's going to touch the x-axis. It's going to have 1 point. And again, we call that a double root. The multiplicity for this 0 would be 2, but that's another story. Anyway, all you've got to know is that if the discriminant is equal to 0, then there's only going to be 1 x-intercept. And then the last thing is if I have a situation like this, where if I go and use the quadratic formula, and it's negative, and what happens is when my discriminant is negative, well, there's going to be no real roots. And hopefully you remember that that's when we have to use the I, the complex numbers. So if the discriminant's less than 0, there's no real x-intercepts, and they're complex roots or solutions. And again, remember the I squared is equal to negative 1. Graphically, what that looks like is our quadratic is not going to ever touch the x-axis. It's either going to be up here or it's going to be down here and then going downward. All right? But the point is, if the discriminant's less than 0, negative, then we're never going to, it doesn't touch. The real x-intercepts, the real numbers are on the number line. The complex numbers, they're going to be up here. Okay, so that's about it. If you took good notes and attempted to do some of the problems on your own, you should be okay. So feel free to let me know if you've got any questions. But good luck on that quiz. Thanks for watching.